A very good morning to one and all present here. We are the project people of SmartCom for Differently Abled, and we are a team of four: Rachna, Rashmi, Rishika, Shruti. We are doing this project under the guidance of Professor Shanti DL. So, we are going to brief you through these contents. Introduction. So, SmartCom it's a wearable device for the communication of impaired using Malosi alphabets. The impaired person can use Glow to deliver messages and the output will be displayed or heard through an Android application. Problem statement. The what is the problem statement is the incapacitated people communicate, they use different methods to communicate, as in tactile signs, sign language, or manual alphabets, or LOM alphabets, and the Malosi, which we are considering here. So, what is the key problem in these is it is not understood by the normal person. So, this project mainly focus on communication between the burdened and the normal person. So, the motivation for our project is so in practice of engineering, societal interests are inherent impact and they exist. Okay, so all engineers as we are responsible for successful project that will serve and benefit the humankind, so they make a difference to the society. The incentive in this project is to remedy support and incapacitated by providing them an affordable means to interact with the conventional world and helping them to lead a common man life. So, literature survey. There are more than 900 conferences and 300 journals and magazines that were published over last year in this field. Fitting like a blowpie is our base paper. Embedded Sign Language Interpreter System for Dumb and Deaf People. This is the paper which we have referred. And Amazing Sign Language Now Can Be Spoken. It's an article written by Newing in May 26th. So a lot more papers we have referred to, and the objective what we have concluded is so it focuses on erasing the communication between an impaired person and the normal person. The user can use the glow and sensor to deliver messages. The message in this way created will be sent to the Android, so using Raspberry, and it will be heard or displayed in the application. So it is a best solution to to interact with the world without any personal assistance. So the technology what we have used here is so these are the six system requirements. One Raspberry Pi, two MPR121 sensor module. So Raspberry Pi it's nothing but a single board of computers. It is developed in UK. You have hardware with several versions and variations of Raspberry. So it acts as nothing but an hotspot or a Wi-Fi server to transfer data to the client, that is Android application. MPR121 sensor module, this is how it looks like. So it acts as a bridge between your Raspberry Pi and the sensors in the cloud. It allows data transfer between them. So the other system requirements is the basic gardener gloves. It is usually made of rubber we have used, and it is used by the impaired person who communicates using Malosi alphabets. So the mobile application is computer programs designed to run on mobile device. It is used to display the translation of Malosi alphabets, and it is used for text to speech conversion. Architecture. So initially the impaired user here, he will use the glove and he will type in the message what he wants, and that will be delivered to your MPR121, and that is sent to Raspberry Pi, which acts as a server which sends the data to the Android application. The Android application will display the data or it will read out the data aloud to the user, and additional feature is this sends a message to the person who is geographically located. This is the architecture. So the physically impaired user, he types in with the globe with sensors, and the sensor data is sent to MPR plus Raspberry Pi, and that is connected to the Android application which sends SMS to the number of users. Module implementation. So initially we integrated all the hardware and then we programmed the Pi, and the program of Android was done, and finally the SMS mechanism using the GSM module was built in. So these are the module implementation. Initially glove integration was done, As
The first step includes embedding the sensor, interfacing with Raspberry Pi, and you have Raspberry Pi as the module 2, that is programming Raspberry Pi interface Pi with the PC. We did testing and then interfacing Pi with Android. The next part what we have done is module integration 3, that is integration of Glow and Android front to Pi testing, and what the advancement is transmission to different locations. The data flow diagram, the inside user wear gloves and with sensors and buttons. So the user will key in the message. The sensor data flows to NPR 121. The data is transferred to Raspberry Pi. In the background, if send button is pressed, it is sent to as an SMS using GSM, and the data is sent to the Android application, and the Android application the message is displayed, and here the message is sent to the users. So there is text to speech conversion and the user will receive the message. Flowchart. First, the program will start. If the sensors or buttons is pressed, if it is yes, it will send the character to the application and text to speech will happen. If it is no, the buttons will wait to be pressed, and then if send button is pressed, if it is yes, the user will send the SMS to the other users and the program will stop. This is the use case diagram. When the press button or touch of the sensor is done, it will send the characters, and then Raspberry Pi will wait for the characters, and then it will display the text and it will also speak, and then if send button is pressed, it will instruct the message in the form of SMS to the other users, and it will send the message to the users. And this is use case diagram, inside user and user with Android. These are the set of functions, that is get cloud with sensors, press the button, touch sensors, send to other users, and user with Android phone, get Smartcom Android app, text to speech compatibility. Testing and validation, this is the screenshot of the connection establishment. So waiting for connection, accepted connection, and this is the terminal which will accept the input. These are the output pins, that is 7, 13, 15, 29 and 31 of GPIO of Raspberry, and input at 12, 16 and 18, and this is the message you key in, and this is the GSM module which will send. The message is this, and this is the confirmation, and it will be sent to the registered mobile. And this is the front end of our Android application. Screenshot of it is displayed here, and this is the screenshot of message received. This is feature enhancement, so we are planning to do it in two-way communication, as in the normal user also can send back the message. And portability, it will be portable to geographically different location without any damage. And compactness, that is the device is it should be very easy to use and compact. Conclusion, so it is a low-cost hardware component device. So it's just made of three things, that is Pi, sensor module and Gardner Globe. And additionally, an Android app is developed to display and listen. It has societal impact, making the life easier, boosting the confidence, and it is applicable and useful in public places. And these are our references. Thank you.